Hello, everyone. Probably need to start that over, don't we? Because we're not even sharing the screen right now. And where did Zoom go? There's Zoom. There. Hello, everyone, and welcome back. Today, we're going to be talking about segment constructions. Segment constructions are typically done with things like compasses, a straight edge, that can be a ruler, a protractor, and since we don't have those things available to us right now, we're just going to hit on a few topics. We're going to talk about doubling. We're going to talk about duplication, what the word congruent means, as well as bisect. So the things that you should be able to do from this PowerPoint are really how to locate the midpoint of a line. And we'll also talk a little bit about the similarities of duplicating and doubling. But the biggest key takeaway here is going to be this midpoint definition and the definition of bisects. So let's go ahead and start with some terminology. We've already talked about what a line is, and we're going to build off of this idea to come up with some other terms. So a line is never ending. It extends forever in two different directions. Here's the notation. We use two capital letters, and the capital letters just represent the points that are here on this line. And if we're going to use capital letters, we need to make sure that we have the line with two arrows extending in both directions on top of these 2 points. Now we're going to start discussing some terms that we have not gotten to yet. The first one is called a ray, and here's a fancy definition. It says that a ray is a line that has been truncated on one side so that it has one endpoint and continues infinitely in one direction. Truncated, I don't really like that word too much. So what you could really do in your notebook is say that a ray is a line that, we can scribble all of this out. So a ray is a line that has one endpoint and continues infinitely in one direction. Now, a couple things to note about rays, okay? The order in which you list your points matters because that tells you the direction of the ray. So I'm going to make sure that we get this into a text box so that way we can put this into our note sheet. So there we go. So the order in which we list our points when describing a ray does matter. So why does it matter? Okay, if I list out A, B, okay, it's kind of like reading a book. I read from left to right. So that tells me that I'm going to start here. This is my starting point, the left side. I'm going to start here at A, and then I'm going to B. So that's the way that the ray is going. The ray starts here at A, and it extends to B, and it goes through it as well. And that's why we see this line over here. So the order in which the points are listed does matter when describing a ray, and we list the points to where the endpoint is listed first. Okay, so in this case, our endpoint is here at A. And an endpoint, if you don't know this already, an endpoint is just where a line stops. That's why segments have two endpoints, because the line stops at 2 points, right? That's why we're able to measure segments, but with lines and rays, we can't measure them. So an endpoint would be right here at A, and it's just where this ray stops. So we start here at A, and then when we go to B, B is telling us which direction the line is going to. So we list the endpoint first. The second point that is listed tells us which direction the ray is going. So in your notebook, make sure that you take these two things and write them down. All right, so I'm going to exit out of this PowerPoint presentation here. Whoops. We're going to clear all the drawings. We're going to come over here to our notebook real quick. Okay, so here's our terminology. We have line, ray, and then line segment. So underneath the line, you just write your descriptor, how you would notate it in an example. With the ray, this is where you would need to put the two things that we listed out of how to describe it, what a ray is. And then down here is where you would put how to write the notation of a ray. And we've got some other things over here on the side. Here's some notation bank. So what you need to do is watch this video first and then go through, document the description for each one of these, and drag and drop the appropriate notation for each term. So we've already done this in the PowerPoint slide, and notice that there's multiple ones, right? So for array, since we just described the ray, this would be that's part of the notation. You also need to make sure that you get, it's not letting me do it. You need to make sure that you drag both things into the box. So there's one ray. This is ray AB. So as you can see, we've also got two other ones. We got this one here and here. It's actually three. So you could drag all three of these and then bloop, put them right in here into this box. Okay, back to our presentation. We're going to continue to line segments. So a line segment, as you can see, it has a definitive start and stop point. And again, we just described what endpoints are, but that's essentially what the start and stop point is. So we have two endpoints for this segment. We have one at B, and then we have another one right here at A. So endpoints are start and stop points. That's what the endpoint is. So endpoint is a start and a stop point. Now with segments, okay, we do the notation very similar to a line, except notice that there are no arrows on either side of this little straight edge right here. Okay, that's because it does not extend indefinitely in this direction or in this direction. So by not having the arrows, that tells us that we have endpoints just like that. And then the order in which this segment is listed, this tells me that A would be here, B would be here, this really doesn't make that big of a difference if you switch these two around. I always like to put them in alphabetical order though. All right, real quickly, we will talk about bisection. Okay, bisection is one of the fancy ways of saying that we're going to split a segment into two different pieces. Okay, and when we do that, what we do is we end up creating what we call a midpoint. So right here, if I were to draw these two straight lines like this, pretend that they're straight at least, what I'm saying is that AB, going from A to B, is the same distance as going from B to C. So these little lines tell us that AB, segment AB, is the exact same length as segment BC. So B, point B, bisects this longer segment, which is called AC. So we're going to write that up here at the top. Point B bisects the segment AC. And what this means is that when I go from point A to point B, it is the same distance as going from point B to point C. Then we can also put in parentheses that B is the midpoint of segment AC. So midpoint, it's not a fancy word. It literally does exactly what it sounds like it does. It's just the point that's in the middle. So midpoint is the point that is in the middle of a segment. So it splits the segment in half. Okay, now the notation that we're going to use here has to do with a term that we call congruent. So congruency is a term that we're going to use throughout the entire class of geometry. So congruency is basically, it's stating that two segments are the same length. We could also use it to state that two angles are the same angle measure. So congruency plays a role in the sense that it shows that two things are the same. So the same would be same size and same length. Now I'm going to come back here to my drawing tool, and the notation for congruency, it's going to go right here in between these two segments. It's going to be a little squiggly line, kind of like this. And then underneath the squiggly line, we have an equal sign. So this right here means congruent. So anytime that you see this symbol, that means that two things are congruent to each other. Here's a different definition of midpoint. It's the point on the segment that lies equidistant or the same distance from either of the marked endpoints. So A and C would be your endpoints. So the process of bisecting, this is bisecting a segment, angle, or shape is the process of cutting it perfectly in half. We kind of already talked about this. This is going to appear over and over and over again throughout the course of geometry. So it's something that we need to be aware of. When we come over to our notebook though, we have lots of practice with notations, right? So make sure that you get lots of practice with that. And one thing that you're going to need to do, because there's no slide for congruent or anything like that. I mean, I keep going down, but here's distance. Here's some angle construction stuff. So there's no slide that has congruent or bisects on it. So there's a couple different ways that you could do it. Number one is you could either A, create a text box up here, and you could just type this into your notebook. And what I would do is I would do like congruent or congruency. And then I would type out the definition. And then underneath it, I would put the notation. And after you've done congruent, you would want to make sure that you made another text box. And you can put this one down here. And in this text box, we would want to do the definition of bisects. So you would type out the definition, type out the notation, you can edit it. There we go. So that's how you would add in the two different definitions, the congruency definition and the bisects definition. And also you want to make sure that you include midpoint. So again, it's one of those things where you could kind of put it wherever. I would keep all this together, congruency, bisection, and midpoint, because a lot of times they relate to each other. So midpoint, and for midpoint, you just need the definition for it. There's no notation for midpoint. So that takes care of slides 8, 9, and 10. And in the next video, we will talk about segment addition, the segment addition postulate, and how it applies to us in geometry. In the video after that, we will talk about midpoint. As always, if you have questions, please feel free to email me or leave your questions in the Google Classroom.